Section 3.2, we talked about summaries you can use for bell-shaped data or symmetric data. But if you have skewed data, sometimes you need to use different summaries because the mean is not necessarily a typical center point for your data. Okay, so for skewed distribution, the mean ends up getting pulled out towards the tail. So if it's skewed left, your mean will be a smaller value than you might really expect, or if it's skewed to the right, your mean might be a larger value than you would expect. Okay, so the idea is we want to find numbers that better represent the data when you have a skewed, or even if you have an outlier. Sometimes you have problems with the mean. Okay, so here again is our graph where the mean represents the balance point on your data. Okay, but the median actually just represents where it separates the data into two parts. 50% of the data are larger than the median, and 50% are smaller than the median. Okay, so your median cuts your data in half. And the median is usually a much better indication of this measure of center that you'd want to use for a skewed distribution than the mean is. Okay, so here's the distribution of Major League Baseball salaries in 2010. Okay, the mean is a little bit over 3 million. These salaries are in thousands of dollars, so we're here for the mean. But the median is more where the bulk of the data is. It's only just a little bit above 1 million. So in this case, it's much better to use the median as our measure of center because it gives a better indication of where most of the salaries are for the Major League Baseball players. Okay, Alex Rodriguez's salary way out here is making a huge difference on our measure of center of the mean because it actually has to add that value in versus the median that just looks at the position of the values. Okay. So to calculate the median, what you need to do is sort the data from largest to smallest. Okay. If you have an odd number of observed values, the median is going to be the middle observed value. Think about holding your hand out in front of you, and if you look at where the middle value is, it's actually your middle finger, right? You have 2 less than it and 2 bigger than it. Okay. Tuck in your thumb, and now, this is for an even number of observations, now where's your middle value? It's actually in between your 2 fingers, right? Okay, so an even number of values is going to end up with the median falling in between two of your values, in which case you're just going to take the average of them. Where if you have an odd value, it's actually going to be the middle value. So the easiest way to find the location of the median is add 1 to your number and then divide that by 2. So if I have 5 observations, if I take 5 plus 1, that gives me 6, and divide that by 2, I get 3. So if you count on your hand, the 3rd finger is your middle finger, regardless if you start counting from your thumb or from your little finger. Okay. Same idea as if you tuck your thumb in. If you have 4, you 4 plus 1 gives you 5. Divide that by 2 is 2.5. So if you count 2 from either starting finger, you end up in between the 2 middle fingers. Okay, so here's some data that represents 8 home prices in thousands of dollars, and we just want to find the median. So the first thing we're going to do is just sort the data from smallest to largest. Okay, so that's this line, and then since there's 8 of them, I'm going to have to take the average of the 2 middle ones. So again, if you take 8 plus 1, you get 9. Divide that by 2, you get 4.5. So I count 1, 2, 3, 4. So that puts my median in between the 4th and the 5th value. Again, I could count from this end, 1, 2, 3, 4, and I get that it's in between the two. Because remember, we actually need to count 4.5. Okay, so I'm just going to take the average of the 192 and the 216. It gives me 204. So my median is $204,000, and that would represent these 8 home prices. So then we end up talking about the quartiles also when we talk about the median. The quartile just means, the first quartile means that you're going to have 25% of the data that lie below it. Think about like a quarter divides your dollar into 4 parts. Your quartiles divide your data into 4 parts. So the first quartile is the value such that 25% of the data are at or below the value. Okay, so it's actually the median of the lower half of the data. The third quartile is a value such that 75% of the data lie at or below that value. You could also think of it as 25% lie above the value. Okay, so your quartile is the median of the upper half of the data. Okay, once you find those 2 values, you can now come up with what we call the 5-number summary. And it just is your minimum, your Q1, your median, your Q3, and your maximum. So when we have symmetric data, we normally talk about using the mean and the standard deviation as numerical summaries of the data. For skew distribution, we use the 5-number summary. Again, it's just the minimum value, Q1, the median, Q3, and the maximum. You might think, well, where's Q2? But Q2 would divide the data, so 50% would be below it and 50% would be above it. So your median is actually your Q2 value. We just don't call it Q2, we call it the median. Okay. So then describe a measure of spread if you have skew distribution is we're going to use the interquartile range. And this is where the middle 50% of the data is. So if you think about this, you just need to take Q3, which is where the 75% are below it, and subtract Q1 from it. Okay, so that gives you the middle 50% of your data. So it's like a range, right? But it's the range in the middle 50% of your data. Okay, so if you want to interpret Q1, Q3 in the interquartile range, okay, if we know the first quartile of birth weights is 3.1 kilograms and the third quartile is 3.7 kilograms, then we can say that 25% of all babies are born weighing at or below 3.1 kilograms. So that's just an interpretation of what Q1 is telling you. Okay, so Q3 is the same idea. It's just you replace your 25% with 75%, right? And then you replace the 3.1 kilograms with 3.7 kilograms. You could also say for Q3, it means that 25% of all babies are born weighing more than the 3.7, at or more than 3.7 kilograms. So I can either word it in terms of 75% or 25%, depending on what, if you want to talk about the percent that are below the 3.7 or the percent that's above 3.7. Okay, and then if I find Q3, that would just be 3.7 minus 3.1, which is 0.6. Okay, so the middle half of all birth weights have a range of 0.6 kilograms. So it's just telling me how spread out is the middle 50% of my data. Okay, so let's look at the distribution of the margin of victory for the NBA All-Star Game. This is the same data you used when you did your activity for Chapter 2. Okay, so I made dot plots of them, and then I've actually included lines here that show the median in red, and then Q1 and Q3 are my blue lines. So if you look at this, you can see that the West won by more points normally. Okay, as in here's my median for it. Okay, now we probably would rather talk about a median instead of a mean because I have these outliers that are out here. Okay, so the mean would be higher than this and actually higher than for both of these. Okay, all right, so because this red line, which represents my median, is above the red line for the East, we can see that the West wins normally by more points when they win. It doesn't necessarily mean they win more games, it's just saying when they do win, they win by more points than the East does when the East wins, and you can see that right here. Okay, so Q1 for the West goes from 4 to 16, and you can actually see that it has a much wider spread for that middle 50% of your data. Okay, versus the East, that only goes from 5 to 12, so its measure of spread for the middle 50% is much closer together. There's not as much variation in their margin of victories for the East as there are for the West. Okay. So the next thing we can talk about is the range. The range is another measure of spread or variability, but it's normally not a very good measure because if you have either a really high outlier or a really low outlier, the range is greatly affected by it because you're just going to take the maximum value minus the minimum value. So it's much better actually to use the interquartile range and talk about how spread out to the middle 50%. Okay, but this is actually fairly easy to calculate. Okay, but if you're taking, let's say, the population to be all 88 counties of Ohio, but you only take a sample of 20 of those and record the population, there is lots of variation in the populations of the 88 counties in Ohio. Okay, so the range is not going to be a very good predictor of the range of the population. Okay, so I'm just taking a sample of size 20, look at the range of that sample, and I can't really use it to estimate the range of the entire 88 counties for their population. Okay, so because the only way that he's going to be close is if you actually pick the largest and the smallest county in your sample, which a lot of times won't happen. Okay, so now let's head over to StatCrunch so that we can look at how to find these things. Okay, so I already made the margin of victory column in StatCrunch. Okay, so I can make a dot plot with it. So I just go to graph, and we're going to go ahead and make our dot plot. Okay, we want a dot plot of the margin of victory, and I actually want to group it by the winning team. Okay, that way I end up with the 2 box plots. Okay, when I do compute, here's my 2 box plots. I hand put those lines on that were on the PowerPoint. There's no way you can get those here in StatCrunch. Okay, so again, there's my dot plot, and you say, oh, I have these outliers, the distributions are not really symmetric, so I'm going to find my measure of my median and my 5-number summary. Okay, so we're going to go over to Stat, and we're going to look at summary stats, and my summary stats are in columns. Okay, so I'm going to pick columns, and again, I'm looking for the summary stats for the margin of victory. And if I want them for both of them, I'm going to choose this to be, we're going to sort by the winning team. Okay, it hand picks some of measures of center you can use, but a lot of these we never talk about in this class. So if you want, you can just get rid of, you can just put in there the ones you actually want to use. And just tells you how many data points you have. Okay, if I hold the command key down, or I think it's the control key if you're on a Windows computer, okay, I can select what I need. So I can use the mean and the standard deviation. Okay, variance is actually the square of the standard deviation, but we don't really use it much in this class, and we won't talk about standard error. And then I can do the 5-number summary. Except I'm going to put the 5-number summary in the order it should be in. So I'm going to, again, I'm holding down the command or the control key. I'm going to click minimum, and then I want Q1, and then I want the median. Again, I'm holding the command key down the whole time I'm doing this, then Q3, and then the maximum. Okay, and then if you look over here, it put them in the same order I clicked on them. That way the 5-number summary is in order that I need it to. Okay, and then for now, I'm not going to worry about the rest of them. I can just click compute. Okay, and from here, you can see that I should have the same numbers I had over my slide. I got, right, 37 times the east one, 26 times the west one. And if you notice, my mean here of 9.9 is almost a whole point higher than my median. And that's a lot because of this one outlier that's out here. Oops, sorry, this one, because I'm on the east. Okay, same thing happened on the west. My mean was 11.8, but my median's only 10.5. Again, on the west, I have this large outlier that's pulling the mean towards that end.